chi-square test. Let us start. There are three tests we have to study in this. First one is test 1. It is the test of significance of goodness of fit. Test of goodness of fit. Test of goodness of fit. That is test 1. What is this? Here we have to check, is there any difference between observed data and expected data? That is what we want to check. Once again, our null hypothesis here, null hypothesis is there is no significance difference between observed frequencies and expected frequencies. Observed frequencies and expected frequencies. Once again, here null hypothesis is there is no significant difference between observed frequency and expected frequency. And in H1, we have to write there is a significance difference between observed frequency and expected frequency. So our null hypothesis is there is no significant difference between observed frequency and expected frequency. Now the question is, what do you mean by observed frequency and expected frequency? So let us take one small example to get the idea about that. Let us assume there is one claim of any of the manager of one particular restaurant that the arrival of customers during the day, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, the flow of the customers during the day starting from Monday to Sunday is 1 is to 1 is to 2 is to 2 is to 3 is to 4 is to 6. This is the claim of the manager. The flow of the customer is like this. Now we want to check whether it's true or not. How can we check this? This is the claim of the manager that the flow of the customer during the day, weeks of the day is 1 is to 1 is to 2 is to 2 is to 3 is to 4 is to 6. Means on Monday and Tuesday, whatever the number of customers are there, we found double of that on Wednesday and Thursday, and 3 times of that on Friday, 4 times of that on Saturday, and 6 times of that on Sunday. That means if there are 10 customers arrive on Monday, then we expect 60 customers on Sunday. That is the claim of the manager. But we want to check whether this claim is true or not. Why? Because on the basis of that, we have to take a number of decisions. So if this claim is not true, instead of 6, maybe it is 7 or 5, we don't know. So we want to verify whether this claim is true or not. So the question is, how can we verify? Any of you? फिर से मैं बताता हूं. रेस्टोरेंट के मैनेजर का क्लेम था कि जो कस्टमर्स उनके यहाँ पे आते हैं उनका अराइवल फ्लो 1:1:2:2:3:4:6 की तरह होता है. ये किसी मैनेजर ने बोला रेस्टोरेंट के. अब हमको चेक करना है एज अ स्टैटिस्टिशियन कि रियल में ये सही है कि गलत है. कैसे करेंगे? कोई बता सकता है? बोलो. एनी ऑफ यू? बोलो. फिर से क्वेश्चन करो. क्वेश्चन समझ में आया? पहले ये तो बताओ. क्वेश्चन समझ में आया है? यस और नो? कोई तो बोलो.
एक बार फिर से बता दो ना क्वेश्चन.
क्वेश्चन ये है कि कोई रेस्टोरेंट के मैनेजर ने बोला कि हमारे रेस्टोरेंट में जो कस्टमर का फ्लो होता है वो 1:1:2:2:3:4:6 की तरह होता है. ये किसी ने बोला, ऐसा क्लेम किया. और अब मैं रेस्टोरेंट का ओनर हूं और मुझे चेक करना है कि मेरा ये जो मैनेजर बोल रहा है वो सही है कि गलत है. तो मैं कैसे ये चेक कर पाऊंगा स्टैटिस्टिकली? ये हमारा क्वेश्चन है. उसने जो बोला वो चेक कैसे कर पाएंगे? बोलो. कुछ तो बताना पड़ेगा ना. गलत तो गलत बोलो तो सही. टीवाई में हो.
सब सब कस्टमर आएंगे उनके हिसाब से, मतलब वो कितने आते हैं और वो सब देख के हम लोग बता सकते हैं ना कि मैनेजर सही बोल रहा है कि गलत. मतलब हमने वीक में देखा कि भाई 600 या 500 कस्टमर आए, तो फिर हम उसको 1 बाय जो अपना रेशियो है उसके साथ उसका वो कैलकुलेशन करके बता सकते हैं ना कि ये फ्लो सही है कि गलत.
वेरी गुड. सही है. परफेक्ट है. सो व्हाट वी रिक्वायर टू डू? वी हैव टू ऑब्जर्व फॉर अ वीक और 2 और 3. मान लेते कि हम 1 मंथ तक ऑब्जर्व करते हैं तो मंडे थोड़े बहुत लोग तो आए ही होंगे ना.
हाँ
उसका एवरेज ले लो.
हाँ
चारों दिन का 4 मंडे आएंगे पूरे वीक में.
हाँ.
उनका एवरेज ले लो तो कुछ तो आंसर मिलेगा हमको
हम्म,
यहाँ पे. चलो मान लेते मंडे रेस्टोरेंट में 80 कस्टमर आते हैं एवरेज.
हाँ.
ये एक्चुअल है कि हमने एक्सपेक्ट किया था वो है?
अरे सर एक्चुअली है ना, क्योंकि जो आए थे
करेक्ट. एक्चुअल है यानी ऑब्जर्व बोलते हैं उसको. ऑब्जर्व फ्रीक्वेंसी हुआ. फिर ट्यूसडे देखा तो 87 आए. वेनसडे देखा तो 152 आए. और थर्सडे देखा तो एवरेज 175 थे. ऐसा करके यहाँ पे तो कुछ ना कुछ तो आए होंगे.
यस सर.
तो ये हमारे पास आ गया. मान लेते कि ये जो था उसका टोटल लेट अस एज्यूम 1900 आता है. लेट अस एज्यूम 1900 आता है. सो ये एक्चुअल ऑब्जर्वेशन हो गया. नाउ व्हाट इज योर एक्सपेक्टेशन? क्या होगा आपका एक्सपेक्टेशन, बता सकते हैं? मंडे कितने आना चाहिए एक्सपेक्टेड? तुम कैसे एक्सपेक्टेशन ढूंढेंगे? तो
जी सर,
अगर
अभी
ये
ऑर्डर।
सही हो, अगर ये सही होता, हमको तो यही चेक करना है ना ये सही है कि गलत है. तो अगर ये सही होता तो मंडे ये जो टोटल है उसका ये रेशियो में डिवीजन करना करके डिसाइड कर सकते. तो इसका टोटल देखो तो क्या होता है, 2 4 6 9 एंड 19. तो क्या करूंगा, 1/19 इंटू 1900. तो यहाँ पे 100 आने चाहिए थे. मैनेजर का क्लेम सही होता तो यहाँ पे 100 आना चाहिए था, यहाँ पे 200, यहाँ पे 200, यहाँ पे 300, यहाँ पे 400 और यहाँ पे 600. दिस इज एक्सपेक्टेड वैल्यूज. तो अब देखो ये दोनों में जो डिफरेंस है, ये दोनों में जो डिफरेंस है, क्या वो डिफरेंस नेग्लिजिबल है कि सिग्निफिकेंट है? ये हमको टेस्ट करना है. उसके लिए काई स्क्वायर टेस्ट यूज होता है. सो काई स्क्वायर कब यूज होता है? फर्स्ट टेस्ट ऑफ काई स्क्वायर कब यूज करना है? when we want to check the difference between observed frequency and expected frequency is negligible or not. So क्या करना पड़ेगा यहाँ पे? स्टेप 2, टेस्ट स्टैटिस्टिक अंडर एच नॉट. फॉर्मूला काई स्क्वायर इक्वल टू सिग्मा OI minus EI the whole square upon EI. I running from 1 to n. I running from 1 to n. Where OI is the observed frequencies and EI is expected frequencies. So ये जो observed frequency है उसको मैं OI बोल दूंगा और ये मेरा EI. अब क्या करूंगा, OI माइनस EI करके उसका स्क्वायर करूंगा. सो 80 माइनस 100 माइनस 20 का स्क्वायर करेंगे तो 400 आएगा डिवाइडेड बाय EI. यानी 400 डिवाइड बाय EI 100 है तो ये 4 आ गया. फिर क्या, ये दोनों का डिफरेंस 13 का स्क्वायर करूंगा 169 डिवाइड बाय 100 1.69 हुआ. फिर ये दोनों का डिफरेंस 48, उसका स्क्वायर करो डिवाइड बाय 200 कुछ मिलेगा. ये सबका टोटल करोगे तो जो आएगा उसको हम बोलेंगे काई स्क्वायर कैलकुलेटेड. सो वी गेट chi-square calculated value of chi-square cal. Here degree of freedom V equal to n minus 1. This is the formula for degree of freedom. And remaining 3 steps are same like as t-test. Step 3, alpha equal to 5% or 1%. You can take any one of these two. Step 4, at level of significance equal to alpha, degree of freedom equal to V. From the chi-square table, we get chi-square 10. So same like t-test, here chi-square test is there. So here we get chi-square table, and from that table we get chi-square 10. And step 5, decision. Listen carefully. Chi-square is always positive skewed. Always positive skewed. Chi-square is a positive skewed. So it's not like a normal. It's like a Poisson distribution. It is a positive skewed means Poisson distribution like this. So here range of chi-square is 0 to infinite. The reason is its chi-square. Square is there. So it cannot be negative. So it is always right tail test. It is always right tail test. You can consider this as right tail test because of this square. So here we have to write chi-square tab, and this is our rejection area, and this one is the acceptance area. So if chi-square cal, if chi-square cal is less than chi-square tab, then H naught is accepted, not rejected. That is, H naught is accepted, otherwise rejected. So this is the way to take a decision in chi-square. So only one thing we have to calculate here, that is chi-square cal. How to calculate? The same way, OI minus EI. So first of all we have to find out OI, then EI. See, OI is normally we have to given in example. EI we have to calculate by using given condition, and then after we have to calculate this chi-square cal, OI minus EI the whole square upon EI, and then we get the answer. So this is the way to solve this type of question. Any problem to anybody? Let us discuss that first of all. Any problem to anybody? सबको समझ में आ रहा है? किसी को कोई क्वेश्चन हो तो पूछ लो. Okay, now let us discuss how to see table. See, this is area in the right tail of chi-square distribution. Chi-square distribution. So here, if your alpha is 5%, if alpha is 5%, and degree of freedom is, let us say, in the previous question there are 7 days, so 7 minus 1 6. So the value for 5% for degree of freedom 6, that is 12.592. This is the way to find out chi-square tabulated. So once we have a chi-square calculated value and tabulated value, we can take a decision whether we have to accept the null hypothesis or reject the null hypothesis. So let us take one small example to get the better idea. See, there is one claim that in one particular library, the students issue the books on Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday are in the ratio of 1 is to 1 is to 1 is to 2 is to 2 is to 3. This is the claim, and we want to check whether this claim is true or not. By taking a survey, we found that on Monday, total books issued were, let us say, 47. On Tuesday, 83. Then 65. Then 108. Then 172. Then let us say 150. So this is the actual data. And now we want to check whether this claim is true or not. So let us start. Step 1, H naught. What is the null hypothesis here? Any of you? You can simply write there is no significant difference between observed frequency and expected frequency. It's okay. But according to the question, if we want to write, then we have to write in some precise way. So what we have to write? The claim of the librarian is true. You can write the claim of the librarian is true. Or you can write the books issued on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday are in the ratio of 1 is to 1 is to 1 is to 2 is to 2 is to 3. So either you can write one same sentence for all the questions of chi-square. There is no significant difference between observed frequency and expected frequency. Nothing wrong in it. But if you want to write more precisely for the given question, then it's better to write according to the given data. So the claim of the librarian is true or the given claim is correct. You can write like this, or you can write the ratio regarding book issues is 1 is to 1 is to 1 is to 2 is to 2 is to 3 on weekdays of a week. And normally in null hypothesis, sorry, alternative hypothesis in chi-square, no need to write h1. Is default assume that it is opposite of h1. So no need to write h1 in first test of chi-square. If you write, just you write opposite. Step 2, there is no such thing like one tail test, two tail test here in first test of chi-square. That is test of goodness of fit. Okay, now we have to prepare the table OI, EI. Here you can write day, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Here observed frequencies are 47, 83, 65, 108, 172 and 150. So now do the calculation, add all this. Please be fast. 47 plus 83 plus 65 plus 108 plus 172 plus 150. So it is 625. 625. Let us reduce 1 from this. So it's 624. If we write if we write 83, even though it's okay. Now what we have to do? We have to divide this 625 into this ratio. So what is the total of this? So total of this is 10.
10.
So 1 divided by 10 into 625. So it is 62.5. Expected frequency may be in point, possible. This is also 62.5. 62.5. Then it is 125. 125. And at last it is 187.5. If we add, we get 625. So this is the way to find out observed frequency and expected frequency. Now do the calculation. OI minus EI, the whole square divided by EI. So what we have to do? 47 minus 62.5. That is what? 15.5 into 15.5. So it is in positive value, divided by 62.5. So 3.844. Do the calculation in that way. 83 minus 62.5 into 20.5 divided by 62.5. So it is 6.724. Now 65 minus 62.5 into 2.5 divided by 62.5. So it is 0.1. Do the calculation like that. 108 minus 620, 125 into 17 divided by 125. 2.312. Now 172 minus 125 into 47 divided by 125. 17.672. And 150 minus 187.5 into 37.5 divided by 187.5. 7.5. Add this, you will get chi-square Cal. So chi-square Cal is nothing but summation of OI minus EI the whole square upon EI. I running from 1 to n. N is 6 years. There are 6 days. So add this. So we get chi-square Cal. Degree of freedom V equal to n minus 1, 6 minus 1, 5. Step 3, alpha equal to 5%. Chi-square tab. See chi-square tab at 5% and degree of freedom 5. For 5%, 1, 2, 3, 4, 5. The value is 11.07. So this is 11.07. And this is obviously more than 11.07. So we can say that if we draw the chi-square curve and if we write, then 11.07 chi-square tab is here, chi-square tab, but our calculated value is more than that, so it should be here somewhere. So we can say that H0 is rejected. So the claim is not acceptable, and we can say that the difference is not negligible. This is significant difference. So our claim regarding the issue of the book is not true. So this is the way to find out the answer. We will discuss this in detail by taking actual example in our next lecture. Any of you have any of the question, you can ask.